Okay, with vectors we can do other math also. If I want to go ahead and add these vectors, then I'd just say 2 plus negative 5 is negative 3. Negative 3 plus 1 is going to give me negative 2. That's the resultant vector. If I was subtracting, again, I'm just subtracting the like parts. So I'd take the left-right portion minus the left-right portion, and then the up-down portion minus the up-down portion. You can also do what's called scalar multiplication, which is basically like saying have two of these u vectors on top of each other and then go whatever direction the v is 3 times. I always think of video games here. If you push a particular button or do something, it's going to go up. It's going to go up, up, and then, oh, okay, it's going to go over, over, however many times. Where would I end up being? So I would think of 2u as 4, negative 6, and 3v is negative 15, 3, and then I'm going to end up adding those things together to get negative 11, negative 3. That would be the result of doing all 3 of those things. So you can do different vector operations like that. Okay. Now a unit vector is going to be a vector that has a magnitude of 1. Just like a unit circle had a radius of 1, a unit vector is going to equal 1. So if I had a particular vector, like say negative 2, 5, and I wanted to have a unit vector in the direction of v, well, I would figure out what is the magnitude of v. And so that's the square root of negative 2 squared plus 5 squared, 4 plus 25. V is not a unit vector. It has a magnitude of square root of 29. But if I wanted if I wanted to have a unit vector in the direction of v, then I could say, you know what? If I had this negative 2, 5, but then I divided it by the square root of 29, or that's the same thing as multiplying it by 1 over the square root of 29, then I could distribute, do that scalar multiplication into here, and say unit vector in the same direction as v would be negative 2 over root 29 and 5 over root 29. In algebra, you would have to rationalize those denominators, but in this class, that's not the primary focus that we're looking at there. So I would be okay with you leaving it alone. Sometimes, if you remember from Algebra 2, we wrote these in vector form. We would say things like negative 2 root 29 I hat plus 5 root 29 j hat. This book does the same notation, except instead of having the hats, they just make things bold. So just be aware that that's what they would do whenever I and j represent the standard unit vectors. Excuse me. So I hat is 1, 0. J hat is 0, 1. Those are unit vectors. This one's going directly to the right. That one's going directly up. So if I have something with this magnitude times I, basically I'm going to the left because it's 2 root 29, but it's negative. And here I'd be going up 5 root 29. So it allows us to slightly change those standard unit vectors in a linear combination way. All right, so we talked about finding the magnitude. The other thing that we often have to do is find the angle. And so this is where all those trig lessons from the last 2 chapters are going to come in handy. But again, this is stuff that I believe you've done in both Algebra 2 and I can't remember if we did it in geometry as much. But if I had v, and again, let's say negative 3, 4. If I wanted to find the magnitude of v, I could say the square root of negative 3 squared plus 4 squared, which that's going to end up giving me 5. And then if I want to find the direction that it goes, so again, if I have a coordinate plane, I'm going to 3 to the left, up 4. So that's 5. I want to know what this angle is, and I can think there that the tangent of theta is equal to opposite over adjacent. And so if I put into my calculator the inverse tangent of negative 4/3, I get negative 53.130 degrees. But negative 53 is down here. It's in fact the exact opposite. So I just have to add 180 to that. And I would get that this direction is 126.869 and some more stuff after that. So that's the direction that this vector goes in. So you can always use inverse tangent on things like that. Let's just stop there.